Okay, if you plug in a -2 here, you just be careful of your order of operations. You have to square the negative first. It's negative of 4 plus 6 is 2. Over here, the limit as x approaches 0 of f of 0, f of x is like f of the limit as x approaches 0 of f of x. So you first find the limit as x approaches 0 of f of x, which is 1. So then it becomes f of 1, and the value at f of 1 is 0. Okay, you guys did a great job with that one. Nice. And then 18, this one was weird. So it's just approximate the limit. Remember, e cubed is just a number, right? So really it becomes e cubed times the limit as x approaches 5 of f of x, right? So the limit as x approaches 5 is 2. So it's e to the 3 times 2, that's e to the 6. And it's approximately 403.4. Okay. And finally, this you have to do in radian mode because there's no degree symbols. So the limit of all of that would really be the limit of the cosine function as x approaches 4, which is 5. So it becomes 2 times the cosine of 5. You type in your calculator in radian mode and you get a 0.567. Okay, good job to those of you who did that. So today is solving with algebra, finding limits. So this is like the meat of the lesson. Like this is like the meat of the chapter of, finding limits through algebraic manipulation. Here we go. Example 1. Did I? My packets. Okay, so example 1. Find the limit of all of this as x approaches 0. Here's the thing. We can find the limit using a table, but sometimes that's tedious, right? We can find it by plugging in. We always want to kind of try to plug in first to see what happens. What happens when you plug in, when we substitute x equals 0 or x equals 0? You'd end up with 4 times 0 minus 16 all over 0, which is 0 over 0. This is called an indeterminate form. We can't determine the answer. It's indeterminate because 0 over anything is 0, but when you divide by 0, it's undefined, right? So it's indeterminate. But in calculus, here's what we do. We're going to use our algebra powers to simplify this. So what do you think the first thing we could do is? Oh, I could square it, right? There is a difference of square. There's a difference of squares, but that's not going to help you. So I would probably just, actually, what did x? Yeah, the quickest way is square double square, like you said, Holden. Yeah. So we're going to say this is the limit as x approaches 0 of 16 plus, what's my middle term? 4x doubled is 8x. Yeah. And then you square the last plus x squared, right? It's 4 plus x times 4 plus x. You could also FOIL. That's just a shortcut. And minus 16. All over x. The goal is to cancel that x somehow, because that's what the problem is. Still, when I plug in 0, it's still going to be divided by 0. So I have to keep going. You keep going until you kind of work that out. That's really the goal of calculus. So, hey, the 16s cancel. And this becomes the limit as x approaches 0 of 8x plus x squared. What can I do, ladies and gents? Take out an x, a GCF. So this becomes x times 8 plus x over x. And then can I cancel those x's? Heck yeah, right? Then this becomes the limit as x approaches 0 of 8 plus x. Can I plug in 0 now? Yeah, right? So what is the limit of the function 8 plus 0 is, the limit is 8. So that's mathematical, right? We try to remove whatever is causing the function to be indeterminate, and we solve from there. Okay? What do you think? It's kind of fun. It's kind of fun. All right, let's go to, should we come back to the your turn problem and go to a different example? Okay. I think I like how when we were doing other lessons, like we would kind of go through examples and then practice the ones you kind of wanted. We can do that. Okay. All right. Let's go to example 2. All right, so we have the limit of this function as x approaches -2. If I plug it in, you're going to get divide by 0, right? It's going to be indeterminate. So x method, yeah, I heard that. Let's x method it up for the numerator. So we multiply -6, add to -1. Can somebody tell me my factors? What are my factors?
Oh, yeah. -3.
-3 and 2, yeah. Divide by x. Leading coefficient is 1, so just 1x, x. All right, factors from the bottom to the top are, so this becomes a limit as x approaches -2. My limits get sloppier and sloppier. How about you? We have to keep writing them. Yeah, until you actually evaluate it, I know. Yes. Because you're taking the limit of it. So it's the limit as x approaches -2 of x minus 3 times x plus 2 all over x plus 2. Until you actually substitute it in, you haven't found the limit yet. So it has to keep writing it. Oh, you have not seen anything yet. Wait till we get to the limit of the difference quotient. Okay. All right. Can I cancel the x plus 2's? Yeah, over multiplication is fine. So this equals the limit as x approaches -2 of x minus 3. May I now plug in -2? Yeah. So -5. Boom. Cool. Okay. Do you guys want to try the your turn problem there? Either one of you? Right. So because here's the thing. I'm glad you asked. Right here, from here to here, I am substituting now in, I'm now substituting in -2 as x approaches -2. Because I can plug it in and evaluate, now when I plug it in, the limit goes away because I am now finding the limit. Great question. Okay. Yeah, it goes away right there. Do you guys want to try your turn 2A or 2B? I think we should try one. What do you think? 2B? 2B. Let's do 2B. Or not 2B. Okay, go ahead and try it.
Stop.
Did you guys reduce in the X method? Check your factors. By the way. And also just a word, at this step that I just wrote, you do have to put parentheses around that 2x minus 1 because otherwise it looks like you're just taking the limit of 2x and then subtracting 1 from it. So you do need parentheses there. And then now we can plug in because we got rid of what was making it indeterminate. Yep, -15. We feeling okay with this? All right. Let's move to the next type. All right, rationalizing. Look at those square roots. Check it out. Okay. So when I plug in 0, when I plug it in, if I just substitute in, I get root 1 minus 1 over 0. That's 0 over 0. Can't have it. So we have to do some algebra. Do you guys know how we'll start? What would I multiply by to change this? You did this on your quiz. Yes, minus 1. We rationalize the numerator, right? We multiply by whatever makes it a difference of squares, right on. So we're going to multiply by square root x plus 1. Oh yeah, sorry, plus 1. You said plus 1.
Good job.
Yeah. And then plus 1 makes it the difference of squares because it's a minus 1. Okay? All over root x plus 1 plus 1. And that becomes the limit as x approaches 0 of, do you want to tell me what the numerator becomes? A squared minus b squared. I'll write the steps. So you don't have to write this step if you don't want to, but root x plus 1 squared minus 1 squared, right? A squared minus b squared. Remember that? A minus b, a plus b is a squared minus b squared. All over. Now, we're just going to write this big old denominator. That's going to be a pain, but we just write it. X plus 1 plus 1. Okay, so boom, boom, those cancel, and you're left with the limit as x approaches 0 of x plus 1 minus 1 all over this garbage. Can I cancel my ones in the numerator? Yeah, get rid of that. The limit as x approaches 0. You got to keep writing that of x over. Hey, can I cancel my x's? Yes, I can. So I'm going to go cancel those. And now, hopefully, we're hoping that we can now plug in with substitution. Does it look like I can plug in a 0 now in the denominator? Yeah. So plug it in, plug it in. I'm going to bring this up here. So we got the limit as x approaches 0 of, oh no, I'm sorry, the limit goes away. Limit goes away because we're now we're plugging it in. Sorry. Yeah, goodness. So then we get 1 over root 0 plus 1 plus 1. And that is square root of 1 is 1. So then it's 1/2. How do we do? Good? Okay. Do you want to see the next example and then do both of those your turn problems 3 and 4? Should we do that? Okay. All right, we ready for example 4? All right. Complex fractions. Yay. Hey, but you guys know how to deal with these, right? I actually was just teaching my trig classes today. This is their first time seeing it. So, let's do this. What are my complex denominators here? Because if I plug in 0, I'm going to get 0 over 0, right? You always try to plug in, because if you can plug in, hey, there you go, you find the limit. But I got to do some algebra to try to get rid of that x. Any takers? Complex denominator, I'll give you one. 4 is one of them. And x plus 4, right? So a complex denominator is a fraction within a fraction. So we're going to multiply this by 4 times x plus 4. Okay, here we go. Limit as x approaches 0 of, okay, when you distribute, you get, do you guys know what this term turns into? 1 over x plus 4 times all that. 4, because the x plus 4 is cancel, right? Imagine crossing that off, and then you get 4. And then minus the 4's cancel, and you're left with x plus 4. Did I write that properly?
Shouldn't it be minus x? I mean, minus.
Yeah, parentheses, yeah. Either write it minus x minus 4 and distribute right away, or use parentheses, right? So all over x times, I'm gonna write 4x. 4x times x plus 4. Okay, wait, I keep going because if I plug in the 0 in this step, it still hasn't gone away. Simplify that numerator, limit as x approaches 0. Distribute your negative, you get 4 minus x minus 4. And these cancel. You get the limit as x approaches 0 of negative x all over 4x times x plus 4. Hey, do the x's cancel? Boom. They do. So then you get the limit as x approaches 0 of negative 1 over 4 times x plus 4. Can I plug in now? Certainly. Plug it in. The limit goes away now, right? Because you are actively plugging in the limit. So it's going to be negative 1 over 4 times 0 plus 4. It's negative 1 over 4 times 4 is negative 1/16. Okay. So here's what I'd like everybody to do, and we have just enough time for this for sure. Go ahead and work on your turn 3 and your turn 4. So do your turn 3 and your turn 4. And then I do have an optional assignment for this. You guys, I'm gonna just say, do what you need to succeed. I said that. Do what you need to succeed. If you need to practice some of these, do that. But please do not do. We haven't gotten to some of these yet, so.
Ethan is cooking.
Oh, 19. Yeah, so don't do 19, 20. 23 or 25. We haven't gotten to trig limits yet. We will get there, but. Or sorry. Or 27. Yep. I'm gonna come around and rotate. And then I think we have a flow chart to fill in after this too, right? It just recaps what we've done, all the processes we've done, so that you know, like, when I'm given a random limit and I don't tell you what method to use, like, how do I figure out what I use? So I'm gonna come over. I think I checked almost everybody's, your turn 3, but here it is just in case.
Miss Alexander,
What?
in your turn 3, you do a +2, right? Not a -2?
+2.
Yeah.
Yeah. Oh, did I not see? You factored it right. But yeah, it should be opposite. Whatever multiplied by like 1 plus and 1 minus makes a difference of squares. Sorry about that. Thanks for the catch. Thanks for the catch.
You'll get the next one. Logan, good job on all that. What do you have to pick? This had 1 over 4 defense.
Oops.
Change it.
Not going really. Root x plus 2 over root x plus 2. Okay.
I tried going. Yeah, they just like, I do very good. How did you suck at boom whackers? You didn't even know anything. It's minus the color. You just like that.
Did we get 1/4
Yeah.
for the first one? All right, how are we doing with your turn 4? Should I write it up?
You couldn't do the boom whackers, right? You couldn't call it.
You multiply by x plus 2 over x plus 2. You get the limit as x approaches -3 of distribute 1 plus x plus 2. Because in the first one, if you need to see the work, basically it's 1 over x plus 2 times x plus 2 plus 1 times x plus 2. That's what I'm thinking in my head. And these cancel. Your denominator. Limit is x approaches -3 of x plus 3, and the x plus 3s will cancel, which is what we want. Evaluate the limit. 1 over -3 plus 2 is -1. Good? Okay, let's recap what the heck we've done here. So turn the page, and this is the last thing for today. And if you can do as much or as little of the optional homework as you want, I would recommend trying a few just to keep it fresh, okay? Do we need to do to succeed? Okay, so in whenever we're presented with a limit, we always try to like substitute it in, right? Using limit properties, if we can. Substitute using limit properties. If you can substitute it in and you don't get indeterminate, that's great, okay? However, look at my note here. Go to the next step if you get a 0 in the denominator with any technique, right? If it all still yields a denominator, you can graph it or check out the table of values. So we simplify if we can. So if there's anything you can simplify algebraically there, right? If there's like any kind of simplification we can simplify, that might help us. Then we move on to algebraic techniques. So like if you can factor, so GCF, difference of squares, or the X method. Okay, factoring a trinomial, however you factor a trinomial, if it's not the X method, whatever, as long as you're getting it right. If we can't do any factoring, there might be square roots in there, so we can rationalize the numerator. Or denominator, like if that's what's causing the 0, or denominator, but it's normally the numerator. So we do this by multiplying by the conjugate, or whatever makes it a difference of squares. Okay, a minus b times a plus b is going to equal a squared minus b squared. If all of that still yields a 0 in the denominator, just graph it and make the table and check out the table. So I'm just going to say use a graph and or table on a graphing calculator. Okay, so that's basically what we've done, and we'll practice again on Monday. And there's still a few more limit rules like trig limits and all that kind of stuff. So, all right.